Okay, so far we've been doing the easy stuff. We've been writing queries that pull data only from one table. It's far more common to need to pull certain fields from across multiple tables, and in fact, that's what makes queries so powerful, is I can get one view or one table or one spreadsheet, whatever you want to call it, of data that came from many different sources. So let's write this query right here. Write a SQL statement that will show all employees who work in Georgia, but we want to show last name, first name, location, city fields. All right, let's go back here, paste that in. All right, so all employees who work in Georgia. Well, that means we're going to have to get name from the employee table and location city from the location table. So let's start actually with what we want to show. It says show last name, first name, and location city fields. All right, last name, first name, and then location city is all one word right here like that. So location city. All right, from where? From employee. So what we need to do now is join employee to the location table. I'm going to get rid of these things for now. So to do that, we say from employee, and then we come down here and we say now there's multiple types of joins. Left join, there's also a right join, there's also an inner join, and then there's a full join, or it's also sometimes called outer join, or sometimes even full outer join. Let's talk about the differences between each of these things here. So let's go back to our nice W3 schools option here, and let's go to their various types of joins to explain these. So I want to go down to, here's our different types of joins. Perfect. Inner. Inner will return all records that have matching values in both tables. So for example, if I have, assuming each employee over here in my Gold Star database that's in my employees table has a matching record in the location table, then an inner join will return all employees and their locations. However, if there are some employees that don't have a location ID, so over here, my foreign key location ID, let's say this is blank, or maybe the location ID is a number that doesn't exist, that doesn't exist here in my location table. For whatever reason, we've got some mistakes in our database, some people, whatever, we've got some bad data, then an inner join is going to ignore any location that doesn't have an employee at that location, and it'll ignore any employee that has a location ID that doesn't exist over in the location table. So basically an inner join will only give us results that has matching records across both tables, and it'll ignore the rest. Sometimes though, we want all of the records in one table, but only those that join, only those from the other table that join up with that table. So that would be a case where we would want all employees, maybe some employees work from home, and there's not a location entry over in the location table, so their location ID is blank or something like that. A left join would say give us all employees and then bring us the locations for those that do match up. As you can tell, a right join does the opposite, and a full outer join says give us everything from both tables, match up those that do match up, but don't worry if they don't match up. Bring us all employees even if they don't have a location, and all locations even if there's no employees at it, and return all of the data. So my question for you then is, what type do we want for the Gold Star data? Well, Gold Star has been super clean for you already. Every record in the employee table has an associated record in the location table and vice versa. So in this case, it actually doesn't matter which join we do. My question to you though is, if we had missing data, which one would you want? Well, for the purposes of data science, which is what most of you will be using SQL for, is to pull data out and analyze it. For data science purposes, we typically want only full and complete records. So if we only want full and complete records, then we're typically going to want to use an inner join, which says only return records where there's a matching record in the other table. So we'll use this example for now, but we might occasionally draw from a left join or right join. And I just want you to know that those are available to you if you ever need them, but this will probably be the most common one. So we're going to say from employee, inner join, and now we put the table we want to join to. So we're going to inner join location. Whoops, location. That's the table name. So it's table 1 name, inner join, or whatever type of join you want, table 2 name. Now, does it matter which one is first and which one is second? With an inner join, it doesn't matter. If this was a left join, then it does matter, because whichever table is first, that's the one I'm going to get all records from, and whichever table is second, that's the one that I'll only get matching records from. If it was right join, then I'm going to get all records from table 2 and only the matching records from table 1. If it's an outer join or full outer join, depending on your SQL engine, it could be one keyword or the other. If it's an outer join, then once again, it doesn't matter what order that's in, because like an inner join, it's going to give me all records from both tables. So I'm going to stick with inner join. Doesn't matter what order it's in, but now I need to use a keyword on. I need to tell it how these two tables are related to each other. Well, you remember from our ERD chapter that there's a primary key foreign key relationship. This is the whole reason right here, this video now, this is the whole reason that you needed to learn entity relationship diagramming, so that you could understand that employee is related to location by using the location ID foreign key matched up with the location ID primary key down here. So this is where we say on, and now we say up here this is all field names, and this has been table names. Now we need to use both. We do table name, employee.location ID, so it's table name dot field name equals location.location ID, whoops, not city, ID. So we're telling it that this foreign key right here matches up with this primary key right here, and that's how we want the two tables or the results joined together. So as a reminder, the structure of a SQL statement with a join is going to look like this: attribute list from table 1 name, inner join, table 2 name, on, and here's where we say table 1 dot, now it depends on if this is a primary key or foreign key, so I'm just going to call it a key, because in this example, table 1 has the foreign key, but depending on which one you put first, table 1 might be the one with the primary key, and it doesn't matter which order it goes in. So I'm just going to say table 1 dot key equals table 2 dot key. And by key, I mean the name of the attribute that represents the key. So this is the structure of a join right here. I'm actually going to copy that and put that in the book. All right. So we've got that set up. We've set up the join. Now we need to enter the criteria. So now we say write a SQL statement that will show all employees who work in Georgia. Perfect. We can do that. The where clause comes after our join. All right. So where location. Now Georgia would be state, right? So location state. So we're going to say where state equals, single quotes, Georgia. All right, let's see. Is that all of our criteria? Yeah, that's it. Employees that work in Georgia. So show last name, first name, and location, city, all fields. We got that part too. No ordering or sorted implied. So let's see if this works. Query return no results. All right, did I spell it right? Let's take a look here. First of all, let's go to location. Oh, here's my problem. State is not spelled out. State is listed as an abbreviation. So I can't say where state equals Georgia. I have to say where state equals GA. There we go. All right, so I've got last name and first name coming from the employee table and location city coming from the location table, but it all looks like one table. So this is very common, especially with data science. We're actually creating a query or a view here, or a logical view, that is denormalizing the database. Remember when we started this whole database module, we taught you that the purpose of a relational database is to normalize the data, eliminate redundancy, and list each location city once, for example. But in data science, when we want to analyze the data later on, it often makes more sense to denormalize the table and put the data back together again. So this is a very common task for you to learn when you're doing data analytics. All right, so that's it for joins on this one.